Hello, Tom. It's great to be back interviewing you again. I have a question that's been on hold for a bit, and it's from Richard. And Richard asks, I wanted to follow up in your discussion with Chad Brown on epistemology, your concept of potential knowledge. I feel I understand very clearly with respect to specific phenomena, beliefs or knowledge should be assessed in terms of probability of being true and in terms of usefulness. However, how would you apply this concept to the body of knowledge as a whole? And more specifically, how would you apply it to the important knowledge connections? For instance, Michael Faraday discovered the important connection between electricity and magnetism, leading to the foundational physics principle of electromagnetism. Following that breakthrough, James Clerk Maxwell built upon the practical understanding about electromagnetism and then derived the Maxwell equations, which have provided the foundational mathematical understandings or knowledge for most of the modern technology that we take for granted. Maxwell's equations were then built upon by Einstein, who worshiped Maxwell. He continued the derivation to provide us with relativity theory and E equals mc squared. Each parameter of this equation actually came from a different source. Michael Faraday, the E, Antoine Lavoisier, the M, and James Maxwell, the C, and Emile du Châtelet, the squared. Separate from this domain of knowledge, take microbiology, for example. This relies largely on insights and understandings from the study of chemistry. There are knowledge connections, so to speak, everywhere, and over time, this has increased exponentially with scientific progress and, more importantly, unification. Can we please expand and further elaborate on your personal epistemology, firstly in terms of the derivation of knowledge, and secondly, in terms of how you see knowledge connections, so to speak? Could we possibly view science and reality as one subject or one large body of connected knowledge that is waiting for us to derive or solve it, like a mega puzzle? Also, please elaborate on the role of deductive and inductive logic within this entire process of knowledge derivation.
Okay, well, that's a lot. So let's try to unpack all of that.
Okay.
First of all, you started out with saying that the things that you gather with your senses, the things you hear and see and smell and taste and feel, you should always be skeptical and realize that believing it as a one that must be true, or disbelieving it with a zero that could never be true, those things hardly ever occur. Usually you're somewhere in between. I think that's 99.99% correct, but you always leave some room for new information that would give you a different probability. So each person keeps their own probabilities based on their own experience about what's true and what's not true. Okay, now we go into science. So with science, there's another process involved. Science evolves by experiments. It's not just you have these various scientists that come up with theory. Theory is just like the hearsay that the individual has. You listen to a theory and you say, well, that seems to work most of the time, so we'll give that a 90% or a 99.9. But then you have to go do an experiment. In science, it's a physical experiment determines what facts are. And usually not just one experiment. It's an experiment that's done by multiple people, multiple places. So after a half a dozen people have done their own experiments in their own laboratories and they all come up with the same answer, then it's credible. But even then, there'll be another 24 physicists that will, do that experiment again and again. And literally, it's done hundreds of times by hundreds of different people. And if they all get the same answer, then we call that a fact. That becomes a fact. And it's a fact by experiment, not by theory. Theory doesn't present facts. Theory presents ways of looking at the world, different perspectives that one has. The theory answers the why. Why is this like this? How can I describe the phenomena? That sort of thing. How does this phenomena fit in with our wider understanding of knowledge? So that's what the theory does. But then the theoreticians have to sit down a while and wait for the experimenters doing the experimental work to confirm whether that theory is correct or not. And typically, theories are expanded upon. All right. Well, we had Maxwell's equations long before we had quantum physics. Well, quantum electromagnetics is a little different, you see. So theories get expanded on, and they also, those expansions need to be validated by not only a person's experience, but by experiments, by multiple people in multiple places. And they have peer review on those experiments. So everybody gets to look at just what they did and how they did it. And the peers decide whether that was a good experiment or a flawed experiment, whether the results are credible or not. So it's a community effort to create what he was talking about as far as the knowledge base, the scientific knowledge, doesn't just pop out of a theory. It takes a long time, many years, many experiments, many people, all peer reviewed, and then we come up with with what we call a fact. Now, often those facts also change. For example, we had Newton, and Newton gave us the clockwork universe. And we learn things that, just from experiment, you just experiment with things and you end up with things like force equals mass times, acceleration, F equals ma. So these were basic physics that were derived just from doing experiments. You let a block slide down an inclined plane and you can compute the amount of friction based on how fast it slides and what its mass is and so on. So that's how the knowledge base goes. But then what happened in the early 1920s was they said, oh, Newton and his laws, Newton's laws, aren't really laws at all. They only hold in that space that's not too small and not too fast. If you go too fast or you're too small, Newton's physics doesn't work anymore. Okay, so what was seen as fact, a law of the universe, then, 100 years later or so, maybe more than that, turned out to be not a fact of the universe at all, but just a fact of the universe within certain limitations of where you apply it. So science has stopped calling things laws. We now just have theories, and we have evidence for theories, and that leaves it open for new evidence to change those theories. And that's the way science works. Science does not work on proofs or laws anymore. We've outgrown that. That's kind of arrogant to think that we know the final knowledge is ours and true and will be true for all time. Very little stays true for all time these days. Science keeps growing, and when it does, perspectives change. And we realize that we're going to do the same thing with quantum physics. We're going to realize that only applies, to a certain subset of reality. That there's more to reality than what quantum physics can explain. So we're going to take another paradigm shift in hopefully the near future to take that next step. So that's how knowledge, particularly scientific knowledge, comes into being. It never gets to the point that it says, this is a fact that will last for all time and forever. It says, this is what our understanding is today. And as far as we know, these equations and ideas are correct, but we're likely to learn new things in the future that will take what we think now and just make that a subset. Yes, quantum physics does apply in a subset of reality, but you go outside that subset and it doesn't work anymore, just like Newton's laws were like that. So that's how science grows. it isn't absolute. You don't have, in science anyway, absolute knowledge, because that then depends on an assumption that you will never learn anything contrary to that knowledge. And that's a bit dangerous. That's a bit arrogant to think that your understanding will last for the next million years. Nobody in a million years will come up with anything different. Very unlikely that that's going to happen. So that's kind of the way that knowledge is described. So individual knowledge is based on experience. The individual doesn't go around doing experiments. The individual gets all sorts of knowledge that he really cannot verify. So he uses that knowledge, perhaps, and sees how it works. If it works, then he builds more confidence in it. If it doesn't work, or it only works sometimes, then he has less confidence in it. So an individual's confidence in the truth of the knowledge he has grows and wanes, waxes and wanes depending on the person's experience. So that makes it very individual. It's not like there is this true knowledge and everybody is trying to find that truth. Many parts of our knowledge are individual. They're not something that everybody has agreed on or everybody sees it this way or that way, particularly all of those things that are not objective. A great deal of our reality is subjective. Most of the things that really matter to us are subjective. In the subjective realm are things like love, beauty, justice. All of those things are not objective. They're subjective. And the subjective world, relationship, connection to others, having parents, having children, all of these are experiences that will change the way you see the world. They're very important experiences. And they come with their own knowledge for an individual, because everyone sees those differences. Now, societies can get together and say, here are the rules that we want, and they may make rules. Rules like, you shall not murder somebody to get their stuff, or steal, or lie, or cheat. But each society makes up their own. Like in our society, lying's fine. There's no penalty for a lie. You tell a lie, you cheat, and it's fine as long as you don't run into a problem with a law. But there's a lot of lying and cheating going on that is not illegal. So, there is no set base of knowledge that defines these things are even good or these things are bad within a culture. Now, what's good and what's bad, what's right and what's wrong does have an absolute value in the sense that if it raises entropy for the individual and for the system, then it's bad. If it lowers entropy for itself and the system, then it's good. So if the net effect of an action, net effect of an intention lowers entropy for the entire system, that's the individual plus everyone else, then that's a good thing. So in that case, there is an absolute definition to what's good and what's not good. But there aren't any entropy meters lying around that somebody can say, oh, your entropy is growing. It's a positive. You're not decreasing entropy. There's no way of knowing that for sure. So there's really no experiment that can be done to show that. That's why it falls into the subjective part of the world. These are things that have no fixed answers. They have answers in a sense that you can grow up and get rid of fear and get rid of ego and get rid of your beliefs. And then your sense of low entropy and high entropy becomes a lot sharper and a lot more accurate, but you're still not in a position to say it's perfect. So in that way, individuals live in a space of their own knowing and their own knowledge. It's personal for much of it. And if you get it right, then you tend to grow up and be happy, and you lower your entropy and the entropy of the system, and everything works out fine for you. But if you don't get it right, if your experience leads you to do things that raise entropy, then generally your life is full of difficulties and problems, and things don't work out for you. So there are consequences. This is shown to be the right way to go that we don't have. We have to each one do our due diligence to try to understand what's the right way to go, what truth is, where the larger truth is, but it's always an approximation. It's never known for sure. The more experience you have, the less fear you have, the more confidence you have that you're doing it right, and the more evidence you get that you're doing it right. But for the average person, most of the time, they really don't know. They have beliefs, they have ego, and they make and fear, and they make almost all their choices based on those beliefs, the ego, and the fear. That's what drives their train. And they tend to make a lot of poor choices, and most people live in a life that's full of struggle because of that. So that's kind of the nature of knowing, of knowledge and information. For individuals, it's not set. Although there is theoretically a right answer, and that is the one that lowers the entropy the most. It's just unattainable to know what exactly that answer is, to 20 decimal places. You can get a rough estimate, a rough idea, but you'll never know for sure, because whether entropy is lowered or not has a dependency on how other people react to that information.
So, to Richard's question, could we possibly view science and reality as one subject or one large body of connected knowledge that
Yeah.
is waiting for us to derive it or solve it like a mega puzzle?
No, it's not quite like that at all. The way that works is that our reality is a virtual reality based on a rule set. Now, that rule set is what we call science. Scientists' job is to find out what the rules are, find out how the reality works, and what are the rules of our reality. So our reality has a rule set. Like gravity is one of those things. You'll never drop a rock and have it fall up. That just won't happen.
Okay.
But there are other things at play. So those rules are always there and they always work. But there are other things that are also, other variables besides just the rule set. And the major other variable besides the rule set is human intention. So perhaps if you had enough power in that human potential, you could let that rock go and it would just stay there or float up, called levitation, you see. So you can affect things perhaps outside the rule set, or have things that happen that wouldn't normally seem to apply, that the rule set doesn't apply to. But that's not the case, because you're only looking at the physical rules of the rule set. If you only look at the objective part of the rule set, then yes, there's a problem there. Intention can override the rules. But that's because the objective part of the rule set is not the whole rule set. There's other rules that have to do with consciousness and intention. And if you take into all those rules as well, then what can happen and what the possibilities are all generally fixed. But those rules that are not objective, the rules that are subjective, depend upon individuals. Some individuals can wield the power to change the objective rules or to override the objective rules, and some can't. So it's not a fixed thing. And those individuals that can do that, well, next month, maybe they can't. You see, it comes and goes. It depends on a mental state. It depends on an attitude. It depends on what you're thinking. Depends on how much stress you have in your life, and how settled you are and how much experience you have. So all those variables will change what you can and can't do on the subjective side. It depends how good your choices have been. If you make a lot of poor choices, then you're not going to be very good at modifying the rule set. See, it's more complicated. Just the idea of saying, well, there is a reality and it just is the way it is, and everybody's just trying to find out what it is and what the rules are, and the rules apply to everyone all the time. It's not that simple. There is a rule set. Gravity. You let go of a rock, it falls down. Okay. But there are other rules in the subjective space that can interact with those rules in the objective space. And that puts a little change, but they're generally not that strong. Usually the subjective rules don't really change things very much. They only change things where there's enough uncertainty to allow that change. So we don't notice it because something really strange happens and we say, gee, that's strange. That's only 1 in 1,000 that would happen. But sometimes 1 in 1,000 things do happen. So you see, only when there's enough uncertainty can the subjective set kind of overrule the objective set of rules. And only in certain circumstances, when people who are capable of doing that, do that. So it's not steady, it's not fixed, it's something that's in play all the time. So it's a more complicated matter than just there is a rule set. That's the physics. And you take physics and you group it up into larger groups of things, and you end up with chemistry. And you take chemistry and you group it up into larger groups of things, and you have biology. So physics is at the bottom, then comes chemistry, then comes biology. And each one of those steps, you're just looking at bigger ensembles of things and how they interact and how they work together. So, with physics, you're talking about atoms. With chemistry, you're talking about molecules interacting, and sometimes atoms interacting, but it's groups of atoms interacting, not single atoms, groups of things, and how do they interact? And in biology, there's lots of different kinds of configurations of these molecules and how they interact together. That's the next thing. And of course, that's plants and animals both and fall into that. So it's just, you take the same kind of rules, but you move them up levels of complexity and level how many players are there in the mix. So physics looks at sort of single players. It looks at what does a rock do when you drop it? What does a cannonball do when you fire it? So that's the hierarchy. And to think that there is just one truth and everybody will obey that truth, that works, but only at a very high level. That doesn't work in the detailed levels because detailed levels are very complicated with lots of different things that can modify them, like intent. So there is only one truth as far as what's the nature of reality like. You come to that truth of the nature of reality. Well, consciousness is fundamental, and that's the truth. And I think that's kind of an absolute truth. So that will always be true because that's just how we are. That's not that's at the top of the pile. At the tiny point of the pyramid, that's up here. That's one of the things that is fundamental. It's going to be that way. But anything else that is subsets and combinations of that, like having humans and animals and plants and an ecosystem and zillions of bugs and other things and how all that interacts and mixes, that is that's based on a lot of uncertainty. Even the rock falling down, there's a certain amount of uncertainty there. And it's not as simple as that sounds. There's other pulls on that rock besides the Earth. The Earth is not a perfect sphere. The Earth does not have a uniform density. So you go, 100 feet away from where you are, and gravity's a little different. It's a little different everywhere. And it changes as the Earth goes around the sun. The sun's pull of the gravity, on things on the Earth, and the moon, as the moon goes around us, it all changes all the time. So even things like gravity is fixed and never changes. It really changes in little bits all the time. There's very little that is just fixed.
Love is the answer. If there's one way to discover this truth that Tom Campbell, physicist and consciousness expert, has concluded it is through your own experience. Give yourself the gift of experiencing yourself. After all, Thomas stated so many times that if it's not your experience, it's not your truth. So learn to experience with Tom's Exploring Consciousness and Everything Paranormal program and unlock those natural abilities for yourself. Discover why love is the answer. Binaural beats included to assist you. Details are in the description below. Thank you.
I and MBT Events hope you like this video. If you do, then you should consider being a Patreon member, because Patreon members get early access to our special content. You will also be able to get your questions answered by me in special Q&A sessions, and most importantly, your contribution as a patron member will enable us to produce the content that you're looking for. So thank you.